YouTube, so you can go back to it. So this is a lecture which I think applies to our studios, both Solshirip and Code. In this studio, we have to apply sustainability in our project. And Professor Mark Brossa kindly invited me to speak about it. So I just collected some materials from lectures and seminars and articles, trying to make something compact, which might be practical for 1 hour lecture, right? Just trying to tell you something that maybe you know already, but sustainability is so wide, so complex, that it's kind of crazy to say something useful in just 1 hour. But well, this is what I tried, so I hope it is useful for us. Of course, in the cover, we have the construction of Beijing's CCTV, one building, one so-called sustainable building. And this is why the question mark comes, right? Right now, everything is sustainable, and we have to be a bit critical with those sustainabilities. So, well, this is self-introduction, but it's like too much. So you can read if you want later. So what are we going to talk about, right? Actually, if we hear about sustainability in architecture, we have so many terminologies. In the 1960s, we heard of bioclimatic architecture, which still exists. The 1970s, ecological architecture is not exactly the same. Green architecture becomes a kind of wide use term later. Sustainable architecture seems to be the standard now, right? And then we have a most recent zero energy and even more zero carbon architecture. Okay, so what are we talking about? Well, maybe about all, but not all of them. One thing is probably we get used to have the sustainable architecture more because it includes some kind of a possibility of economical possibility, right? It's not something that is ecological, but something that we really can afford and can use and can maintain. This is why sustainability came into play. And there's one more term, which is the eco-friendly architecture. And I would question it. Eco-friendly architecture is kind of nonsense. There's not any friendly in any science. It's kind of a salesman and politician word. Did you hear in mathematics some kind of a equation-friendly algorithm or something like that? Yeah, so I would avoid it. Probably it comes from the Tsinghua, right? Hua probably harmony, which you translate as a friendly, right? But Huangyo and Tsinghua, but it's Tsinghua, okay, this is linguistic. In English, it becomes mainstream, but I would just avoid it because we have a lot of eco-idiots around, and that's enough already. So, and then sustainability, there's a lot of emotional things about it. There's a lot of attitude, beliefs, politics coming on. We have the skeptic, the clever guy. Yeah, the only sustainable building is the one that has not been built. Yeah, that's true. But it doesn't help us, right? But then we have the naive, to be kind. So this building is eco-friendly because it's a LEED certificate, it has solar panels, it has shading, it has louvers. This is quite silly. So it's kind of being confusing some kind of gestures and additions to the real thing. So we'll try to avoid both attitudes and go to something more practical. And of course, what is published doesn't help. We have the comparison of the famous Seagram building, masterpiece of modern architecture, but in 100 points, this is about 100 points, right? The performance of Seagram is 3. It's like the worst building in the history of architecture. Then we have the newest, World Trade Center Tower 7, 75. It's a wow. This is like 25 times better than Seagram. And this kind of success and this kind of model, there's LEED platinum and it has all the certificates and whatever you want. But if we compare to PT Chrysler building 1930, it's a little better. I'm not totally fair because this has been renewed, but it's not difficult to match and even become better than the most celebrated building. So there's something that doesn't work, right? So this is why you should be maybe not totally skeptic, but quite critical about those ratings and those publications and those victories of sustainability and eco-friendliness. And then there's many things which are very difficult to categorize. I on purpose took, this is a Burgos Cathedral in Spain. This is my dad's hometown, right? And this is 13th century. Also, it has additions later. This we all know, right? So there are two buildings which are crazy. They are anti-economical. They make no sense. They would never pass. Well, he passed for sure the elite, but how can we judge them? So there are points in which this building has been already over 700 years like there, and the identity of one community, right? Actually, my dad and everybody of that town is very proud of this building, and they do whatever to sustain it. Can we say the same about those towers, those buildings, which are much more kind of the glory of the corporation itself? So this is something which comes beyond the case, but again, not everything that is energy efficient is just energy efficient. I would question it, right? It's just sustainable itself. Well, there's many more layers that we really cannot comment, but I have to say it because really the sustainability is like a really wide subject and we cannot get too narrowed. Let's go to one example in Seoul. Actually, it's a good example. You might be familiar with Seoul Energy Dream Center. It was opened in 2013, and it was one of the most advanced buildings in the time, and now it's a good reference. It has many good points. So all the design has perfect natural light in all spaces without too much glare. So the design itself took care of natural light, which we know is much better for human performance than any kind of artificial light. This is the engineers with one of the students visiting the building, and they were checking the building real performance for at least 1 year after constructed, because we know things, projects are not ideal, so very few times you see that. And of course it has the shading automatic in those facades which cannot be slanted. So you have automatic shading where you need. And with that result of savings of energy, of course, there's a huge insulation. So for the little bit of energy they needed, they have the most advanced systems of green energy and heat recovery. So that building actually is, well, of course, solar panels and high efficiency climatization systems. So that saving in active systems allowed to have a much more quality, much more efficient systems. So the summary is like a really, the design, this important thing. Before you do any calculation, design may help. In this case, they reduce needs up to 80%, right? Of a baseline of 2013, of course. But that means that the 20% remaining can be applied to the clean energies and higher efficiency because you need much less. Something interesting as a radiant floor for heating and cooling. We are used to the Ondol in Korea, but the cooling actually works very well. If you can visit that building in summer, you have a radiant heat, radiant floor cooling, the ground floor, and air-conditioned, high-quality air-conditioned, the second floor. You will see the environment is totally different. So, and of course, it's automatic and so on. But there are also drawbacks. The building is extremely complex to manage. And actually, you need full-time engineers to make it work. And that's one of the death points of many so-called sustainable buildings. People are not able to manage them. And then, well, it's from the exterior. Actually, one of the students, when saw the building at first sight, said, oh, this building does not look sustainable at all. And the German engineer laughed. You know, well, why? Well, it's not only not perfect construction, which is pity, but this is a very high-grade polymer, right? This is a Korean, which is extremely expensive, but has a huge carbon and energy footprint. So it is great. You have ventilated cavity, you reflect light, and so on, and it's long-lasting. but there is a huge accumulation of energy there that it will be very difficult to pay back in the life of the building. And there's something that's surprising. The structure was not German calculation. And we were all surprised. It was so extremely oversized. And again, this is using too much material, which has a huge footprint also, just because of the habit of how doing things. And we have this small problem, which we saw later. The solar panels are under the trees. So there's no communication between teams, and they are mostly on this shade. So the performance is terrible. So management is complicated. This is important because we build for human beings, right? And as human beings, we like to open the window when the weather is good. And then the system doesn't understand it, and the computers collapse, and you have a real disaster there. So it took some time to get used to that. Then the construction itself has a huge carbon footprint, right? And that's not told anywhere. So probably it will take over 100 years to compensate for that. And I'm just reducing. We have some calculations later. And of course, the poor coordination between teams, like the tree shading, something that happens. So what does this tell? We have a building which is extremely energy efficient. That's a success. But there are things that do not work actually, right? And it still accomplishes its function. So it's a didactic place, and still we can go there and really learn a lot about good systems. But what we say, it is sustainable, it's not. Well, it's very hard to give a reply, right? It's sustainable in some aspects, could be better in other aspects, but still it accomplishes its function. And there's many things which are untold. This is like a gossip. So don't tell this out of the classroom. So the first project had an underground building because it's most efficient thing to make. But government, no way. We need an icon, something flashy. People need to see it. We need a futuristic building. So that's a big drawback, which accounts actually for one of the drawbacks of this building. Well, actually, the design, except for the graphic design, which is terrible, the design is quite decent, so I cannot complain about it. I wish we have more than this. And then, you know, the design is finished, all calculations done, we can continue on ourselves. And I hear this a lot here in Korea, especially. The rest we know how to do. But then, come on, this is too complicated. Let's call back the engineers, right? So this in between also accounted for a lot of mistakes. And this is this kind of arrogance of thinking things are easier than they are. And the engineers came and say, okay, what happened to the structure? What is this, right? And this continues or not. So again, what's the question? This building is sustainable or not sustainable? Actually, you cannot say just yes, not, right? So we have to see the context of this building, its function, and we have culture, economy, the ecology itself. So many things to speak about. So I wish we speak more on levels or degrees of sustainability, right? And as in the case of this building, we have to make many trade-offs. It will be very difficult to make always the perfect project, the perfect design. So the work of the architect, I hate to call us designers, but okay. The work of the design actually consists on taking decisions, right? And the perfect project, I don't think it exists. If it exists, it's just an exception. It's just probably a very unique happening, right? You always have to favor some things and others based on the context and the needs. So this is one thing I put in the lesson. So when I teach sustainability, I try to widen into 5 chapters because I don't want to complicate too much. So 5 is compact. In general, we speak about probably 7, 8, 9 categories. And with relations, everything is related. So it's very hard to isolate problems and to say them just by separate, right? Everything connects to everything else. And the user, client, and the building is one of the most always forgotten. So we think everything is design, and as we saw before, not everything is design. There's many things involved there. Well, still things missing around here. Okay, you can even complete this. So let's go to our project. So say, okay, it's very nice talk, but we need to make our project. We need to take decisions to have a good grade in Design Studio. So one thing which is upon our heads. The 2030 was something which started in California and somewhat applied to the rest of the countries. So the idea was to have to be full carbon neutral, right? No fuel by 2030. And the idea was to design better and then to apply, as in the case of actually Solar Energy Training Center, to apply for green energies to account for that, right? So that's kind of energy and carbon neutrality. Again, that was before. Actually, that called for most countries to take decisions to have a neutrality by 2030, and Korea is not an exception. We are 2021. So that means that when you graduate, you will have to comply with those things. And we are struggling still with the regulation we have now. So it's something serious. So we have to save a huge lot of energy. And that's the point. And saving energy means also less carbon emission. What can we do? I will tell you something which is not so much politicized. I don't know why. This comes from research we published like 5 years ago. And you don't need to go into the small print. We just compared a block of one-family houses and the same number of living units in the small block, right? We compared all the cost on the carbon footprint and energy of urbanization that's making the streets, infrastructure, building, and then the use of 10 years. The use of 10 years is easy to understand, but also after 10 years, you have renovations, right? And that complicates a lot the calculation. And this for Spain. In Korea, many renovations start in year 1 or year 2. So that's really hard to. But what is surprising here is that urbanization plus construction accounts, in the case of terraced houses, for 93% of whole carbon and energy. In the case of flats, a bit less, but still it's like 90, how much? 92%, right, of the total. That means that while we always speak about improving the 7%, this is the life of the building, or that 8%, say we become even 20% more efficient, okay, that will be having a minimum impact, while most of the harm is already done. In summary, it's 92% during the construction. That means that the way we design, the way we detail, the way we decide in our project has much more influence than the real performance of the building later in its life. And the research is consistent with it. This is another publication which says the same. The moment the buildings are more energy efficient, the energy lost in the construction, right, is much bigger than the one in the exploitation of the building. And of course, we have to consider the demolition, which is another matter which goes beyond us. So with this background, you already have a powerful tool. You have to know that telecalling is annoying. So teleshopping, or what's the telephone promotions. Okay, so you know now how much, if you're sincere about improving the environment, you know how serious is our work as the ones who plan and project the buildings which are built in the future, right? Because we account for most of the pollution. So good design and construction is really necessary. It's not something that we take for granted and we say, okay, we just copy things. We really have to make an effort to make construction better. And not only our detailing and our choice of materials, but how construction is done. You will not see electric powered trucks in the construction site, right? I think it's dirty, inefficient, and enormously polluting. And that happens also with the fabrication. So we have a lot of work to do. So bottom line, that's very obvious, but we have to make sure we build only what is necessary, right? And reuse comes always before demolition if it makes sense, of course. Second, building to last. So the longer the building lasts, the more we compensate for that initial cost. In the calculation before, we need over 100 years in that Spanish calculation to catch up with the initial footprint, right? Just by energy savings, and probably more. And the more efficient the buildings are, the more that footprint is negative. And that goes to the design. So we have to choose our materials very carefully, both for footprint and life. And that means also maintenance, positive replace, and the not reconstruction, but deconstruction, right? This is a concept I don't have time to see here. Here we can go only over general things. And I think I'm extending too much already. But as it happens with cars, the easiness to take one piece out and replace it by a new one is something that all industries, not all industries, actually used to do, right? But in buildings, we are now renewing our facade in the building we are now. You have to make a hell of a demolition, a real mess. And I wonder if the result will be better than what we had before. So things to consider. And then again, I think this is cultural. What is the benefit of rebuilding every 30 years? In Europe, people cannot believe that those apartments built in the 1980s, in the 2010s, are demolished, rebuilt with a quality and with a design that will be needed probably to demolish in 30 years, because the quality is so low that those buildings burn old. So we have strategies. First, passive design, right? Once we choose our materials. And the example of Seoul Energy Drink Center is great. You have the correct use of sunshine, shading, natural light, very important, ventilation, insulation. So in general, you can reduce the needs by 70% or more, only by these strategies, right? And well, it's taken from one book, but that psychometric chart will help you. So we have a quite wide comfort area. Seoul is a bit difficult to catch here, but probably is overlapping several climates, right? Maybe it's around here, right? So in great part of the year, you can just have a perfect environment without adding active energies. So it's could be nice that you are familiar with it. And give the possibility just to use, to open the windows, to use the daylight and things like that. And that makes for a big saving, right? So as I said, there's no way to give you a kind of system to design sustainably, but I can give you some points, some hints, which affects especially design that may help you. First is the excavations, right? We start from excavating, and underground buildings, as in the case of Seoul Energy Drink Center, would have been nice, but how many basement floors do we need, right? What happens to the underground when we excavate? And what happens to the debris from the excavation? There's things you have to consider when you plan those huge and beautiful sunken gardens and those underground spaces for more efficiency. This is the section of a typical medium size of this tower in Gangnam. Gangnam is riverbed. So you have probably 4 or 5 basements, under the water, right? How do you deal with this? The only tool we have now is to pump the water out. How much? We don't know, because we have so many buildings. We have thousands of buildings doing that. But if we go to the published material of the subway of Seoul, which uses the same system, pumping 24 hours a day, 7 days a week, lines 1 to 5 pump 70,000 cubic meters per day. That will be filling the need of a 500,000 people population. And more deep, lines 6 to 8, we don't have the new ones, almost 3 times as much. So altogether, in one day, the needs of 2 million people, right? And not only that, but when you pump water, the natural ground level of water goes down. So you have a lot of imbalances in between, which alter the geological system. So decision of excavation is important. And I bring one example. What happens to the soil? Well, this is the famous Summer Palace, north of Beijing, right? That hill you see on the bottom, which is enormous, is just the debris of the excavation from the lake, which is quite reasonable. And you would not be surprised that good architects very often use those elements as part of the landscape. This is a pity. This building that was demolished, I think, last year or 2 years ago. But when you make a big excavation, think what to do with that excavation material. First, excavating by itself is not bad, but you have to deal with a lot of debris. Otherwise, it will have to be transported to the sea, most common, to make Korea larger and greater, but not necessarily much more ecological, because that's, again, changing the ecosystem and increasing transportation and costs. So 1 point. Second, structure is the second element we built. And probably we can go back to old materials. And then those very cool buildings which challenge physics, what's the real cost, right? And means, right, how much is the cost of building higher? And then how healthy is steel? Some questions. There is a rebirth on timber use. Curiously, we found out this great material. And I brought one example. Yoshiaki Amino is one of my Hube in Japan, very much expert. He studied in Europe with the best experts in timber. He did 6 years ago a very nice house in which structure, partitions, facade, envelope, even roof is done with the same timber logs. He went to the workshop, said, give me the timber nobody wants, the one with most effects and the ugliest and the cheapest. So he cut in standard size and they just devised a way to put them together. And this helps to have a building. Of course, the design has a lot of very interesting things. But the point is we have only one material. Of course, you have a waterproofing and some other things. You have glass also, things like that. But that's enormously ecological. In our country, in a place where you have overproduction of timber, for example, that's another matter. And apart from Japan, we have to go to Northern Europe, right? So Norway, all that Scandinavia have a lot of experience of wooden timbers. So right now, the tallest towers are built in those areas. We have already 6 years, one interesting building. Just this summer, we have one of the tallest buildings. 20 floors is really amazing. So I encourage you to research this, right? You don't need to go very high, but you have many possibilities. And this is just a glued laminated timber and cross laminated timber, plus some steel, right? Steel. And some concrete at times. Not sure in this case, but sometimes you need concrete to achieve some fire protection or insulation actually, and sound protection also. But that's another thing. But most of it, again, it is amazing. We can have 20 floors with material. And who knows? Toyo Ito. This is again quite a recent project in which he experimented with long spans, which is another of the areas where timber is very much competitive with steel and concrete. So innovative that they have to make models and mock-ups. Those photos are the mock-up, and the mock-up is huge to make sure it works, because there was not experience in this kind of building. And you see the scale of this construction. Making this in concrete or steel would have been probably prohibitive. So there's a lot of things about it. And then, of course, still remains. And I go to one of the icons. This is also eco-friendly, of course. If you go to the CCTV and OMA, they did great. And it's fantastic because you see the facade is just expressing the stress of the structure. So the building is expressive. I don't know the guy who works here, he's very happy about it, right? But what is the reality of this? Okay. The amount of steel used here is humongous, and you will very seldom see these photos. Some guys said this is kind of the steel savings back of China. When you need steel, you demolish this building, you have steel for a long period of time. And then this is what happens. You have a very expensive tower, but to make it work, you need really useless space, right? And again, compare this with the cathedral we saw before. Right? What is the greatness of those spaces? So, and then let's go to just comparing data. And I don't know how much we can believe the published data, but a conventional building may have as little as 30 kilograms per square meter of construction. Probably up to 20 floor, which is the usual high rise here, maybe twice as much. One of the buildings, Bishop Palace, I think this is Renzo Piano, I'm sure, which is quite slim and quite well designed building. It has already almost 3 times as much steel. And CCTV Beijing wins all of them, right? So it's like almost 8 times as much as any other building. So you have to be very aware of that. Again, there is not thing intrinsically bad in doing high rise, but sometimes we have to see what's the benefit of those crazy buildings we see around, apart from publishing and the glory probably of the designer himself. And there's one more thing. Still is very safe and unshakable, but you see how we apply the fire protection systems. Fire protection systems often have very nasty chemicals. So we have to be careful when we apply them and how we conceal them during the use. So we have those beautiful beams and columns, which better we have to hide them if we put those materials on it, right? And there's not only that, still needs painting. How much? Because painting, again, is one of the most polluting chemicals on Earth, right? Eiffel Tower has to be painted every 2 years. It's no less than 50 tons. How about another of towers, Leadenhall Tower in London, one of the new ones? I found data. It's 500,000 kilos of paint. This is about 3% of the structure weight is painting. The good point is that this paint probably will remain for a long time. You need to change every 2 years, right? But it's something which we have to be aware of. Let's go to the envelope, which is the next part where we work. And because we have not much time and I don't want to overwhelm you, I left out all the interior materials, but actually interior is a big thing and we create the spaces, so we should have to talk about it, but okay, we have so much time. Again, there's a lot of publications, so I encourage you to find information, to get educated and use the handbooks. This is one example of very popular example, Building to Suit the Climate. This is mostly a handbook, right? And you don't have much theory there, but it's kind of useful. There are plenty of those for you to become better. And then you have a set of strategies you can use with the advantages, the inconveniences, how they could adapt to different standard climates in the world. This should be the starting point, right? And again, you have probably all possible standard strategies, but not always they are positive or they're necessary or they're adequate. So you have to really educate yourself. There's not any pride or benefit of being ignorant, right? So really, really, you depend so much in your own knowledge and understanding of things. Then the handbooks help. I will give you an example. I'm very shy to show my work, but I did this in 1985. 1985, I just graduated. So I did not even know the word sustainability. Because actually, I think it was defined that year later. So it's a small house for my family. And at that moment, I think it's common sense. You look for sunshine and try to make a lot of insulation. So 1979, that's 6 years earlier, it was the first time we have a code limiting the transmittance, the U failure. And that time, 25 millimeters of just the EPS was the standards. Before that, we never used insulation, right? Things changed so much in those years. And the intent, of course, minimalistic construction, standard techniques, over insulation at that time, thermal inertia, because the difference of temperature day and night is enormous there. To have a solar light and heat, and in winter and shade in summer, you have to cross ventilation and stacking. There are things that I think it's kind of just common sense, right? I feel shy just to repeat it. It's kind of things which many people who ever lived in a house should know. The building is quite simple, actually. It's just a very simple volume. Open is mostly south, southeast, right? North almost complete. So the design did not calculate the shades, that's the intuitive thing. And the thing which was unique here was the section. And it's very clear, I did by memory. It was just a load-bearing wall in brick, just 1.5 brick, 32.5 centimeters, air layer with I think 5 centimeters insulation, and then outside break with render. So the insulation part was on the outside. You have maximum thermal energy on the inside, right? So at that time, right, the construction company says just second insulation is too much. What is the need? You're wasting time. We're wasting money. And then thought that I was mistaken. They thought it was the interior, it was the exterior, right? I had to tell them, no, we're building in the opposite way this time. But actually, it works. It consumes very little energy. You have very much nice climate, and it's extremely easy to use and cheap. And people said, well, on the outside unit is ugly, but this is the neighbors. But I saw the inside, and it's so beautiful. I didn't show the photos of the inside. You may have a different opinion. But, well, right now, we sold this house, and it has the third owner, and it has been renewed. And that means that after 85, so that means 35 years, the house still keeps its life, and we don't need to demolish it. It was a nice, well, not because of mine, but now life is much more complicated, right? So we have to design good envelopes, but we have a huge amount of challenges. And one is the codes. The codes help, but are not the solution. It's the bottom line. As we did in 1985, sometimes you have to think away from the code and try to find the ideal. Also, you don't get always good. This is something that happened a few years ago. It has changed, but Nari Kim, Sun-Ho Kim, which are friends working at the VSA here in Seoul, they questioned the regulations because the simulations did not match at all with the code, right? And they found out that the code was very insufficient and took things out. So where you have an EU value of 0.6, actually the value was 0.17, you had like a much, almost 4 times as much energy loss. This has been fixed, but still it's good that somebody just think beyond what it's published. Don't think that the codes are always perfect, and we should always try to improve them. Second, as we said, design is one thing and construction is other. Design is about intention, right? And design, in Spain, we like to use a better project. Actually, the design studio is projectors, yes, project, of course. But because this is a projection into the future. So it's like you have the future, and you draw it now. So you're advancing the future, you're guessing the future. That means the future is something we can only guess. So the construction and how people use, right? Construction and use, something we never know. So we have to be very aware of that. No matter how strict is the code, no matter how perfect is our simulation tool, simulations are always simulations. Reality is always reality. This is what happened, and I think it's one of the good points of Seoul Energy Dream Center. It was checked, and it had to fix a lot of things. And this is one of the most embarrassing examples, but it happens every day, right? This is already almost 20 years. But in 2002, this was like everybody, when it was published, we all said, wow, right? Yoxi, Foster, right? But actually, when the building was checked, the score was worse than every day's building. And that made us think, well, what's happening here, right? Then we understand that insulation is the base. Well, this is one of the important things to keep the energy inside, but our technology is quite limited. We are almost in the limit of what we can do with the insulation we have. This is the current code for Seoul, right? Look at one thing, which I think is enormously unfair. Why non-residential buildings have to be more liberal than the residential buildings? Why is that? Do they use a different energy than the residential? Why Samsung in his offices can spend twice as much energy as I can do in my small, pretty house? So this is one thing which make, again, us question those regulations. But again, for facades, this is like a really strict, right? Especially for housing. And for windows, especially residential, this is almost the impossibility for glass. And it's not only glass, it's glass plus sash, right? And if you go to the coldest zone, you are really, really pushing things to the limit. And this is why, if we use fiberglass, which is the standard, the U value and the thickness is not linear. So you don't have twice as much insulation with twice the thickness. This is asymptotic. So there's a point like about 40 centimeters in which increasing the insulation has very little benefit. We are now about at the 20 centimeters, right? And we have 0.2. Just applicating will go to near to the 0.1. But then we will have, and then who wants to have 40 centimeters only of insulation? That's a huge waste of space, and space is very valuable thing. So we have a limitation there. Of course, we have the foil insulation, but I cannot help you here. I have received visits from sellers from the late 1990s, telling this is great. When I ask for the certificates and experiments, they never give me, right? And this is what they use in the space station and so on, but it's very, very much specific, very, very much experimented and very controlled setup. Buildings are a mess. So the bottom line is that foils need to be in an enclosed cavity. And even so, US codes give them a resistance of 1 for cold regions and 2, apparently it works better with heat. But again, this is just codes and it's kind of empirical. We don't know very well. So may work. The problem with reflecting insulation is that our insulation calculation is about the transmission. And we know the physics. About reflecting and how it affects the interiors of buildings, I don't think it is yet an agreement or a clear formula. So this is something that you may consider because it's really thin, right? That's great, but I'm not sure about how efficient. New materials, aerogel, that's great because it is non-flammable, fantastic. It is very insulating, but it's terribly expensive. Still, you can use it in very small areas, difficult parts like thermal breaches and so on, and it will help, right? If we compare fiberglass with aerogel, actually, with fiberglass we need 20 centimeters, with aerogel we may make with probably 6 centimeters or so, right? Which is a big difference. But at some point, when you go past the 20 centimeters, again, I don't know if we can afford for that. You see that the real benefit is very small. So again, insulation, we can do so much in a very small way. And then the flammable insulation, this famous ISOPINK, right? Well, the fire of 2017 was really terrible. And people were thinking, oh, come on, this was a metal facade, how can it burn? Well, because it's made with polymers, but we have Hyundai a few years before, Ichon last year, a similar fire in Madrid this winter, one other in Milano this summer. Fortunately, without dying people, right? I don't remember Hyundai, Ichon, probably 5 or 6 people died. It is all due to the use of those flammable materials. Ichon was a bit different because it was kind of a flammable material used in the interior, which is quite pity. How can people die because an interior construction in one apartment in a building? Anyhow, probably Korea is one of the few buildings which still allows to have these flammable compounds in facades, and that's a problem. And this is what they said in Eiffel Tower. We have the AlucoBond, which, by the way, is the material we used in our newest building, new engineering building, of which I contributed with my salary to build, has this flammable AlucoBond in the facade. So can be proud. And they said, okay, had they used the AlucoBond Plus, which is fire retardant, you see the retardants, core, probably it wouldn't happen. But you see, plastics are never fireproof. You have retardants only. And those retardants are chemicals that probably kill you before the fire. You're exposed to them. That's another matter. So this is taken from my materials class, right? So fire-resistant plastics actually are just flame retardants, right? And there are things you have to take care about, but that's the point. Very careful with plastics in facades. I have very good friends who do fantastic buildings with the plastic facades, but I wonder how they deal with fire. Okay. Then we have the glass. Double glass is not anymore the norm. We need at least 3 layers of glass. And I don't see it using. You have here a comparison, of course, the interlayer of argon or krypton. Krypton is more expensive, argon is expensive already. So krypton gives you an advantage, so you have better insulation value. And of course, if you use krypton and 3 layers, you win over any kind of glass, right? So that's Great. But what's the problem? If we have a triple glass, we are losing, at least in the best case, half of the light coming inside. In many cases, 70%. That is very good quality glass. I've seen in the market glasses in which you lose, or you already receive 50% of light, right? So if we put windows to have natural light, and we have to put so much glass to have more insulation, but we have to have the artificial light all the time, what is the advantage, right? And of course, glass is heavy. So glass is like a stone, and sheets of glass weigh a lot. And plus 50% of weight in glass will affect a lot, especially in high-rise buildings. Towers are very sensitive because you multiply by a lot of floors that weight. So we are another bottleneck. This is the World Trade Center Tower number 4. My associate, my professor, so I was able to sneak the detail in his office. I couldn't take photos, but I sketched it, right? You see, it has 4 layers of 8 millimeters of glass. That means 32 millimeters, am I right? Yes, of glass. Try to look through a 32 millimeters glass stick. So this very, very special glass with all the coatings and with the fabrication which allows you to have a reasonable transparency in this building. And of course, almost 20 centimeters of insulation in the spandrel just to achieve the value you need, right? So those towers we see everywhere with just a double layer of glass are kind of a joke in terms of energy performance. We have a new technology. So thin glass is a new product. We can have glass less than 2 millimeters. It is still not commercialized. And I'm losing the battery. Just a moment. Can I have a battery extension? I can do it myself. 1 second. Don't run away. You see, energy. Okay, now we are back. So again, this is very expensive and I didn't see it commercially yet. But again, that might help to have this 3rd layer. We may benefit at some time, right? And of course, there's more ideas. I have some things, again, this is stolen from polished material from my friends, but it is nice to see people trying to think out of the box and find solutions for things which are difficult. How we can reduce thermal breaches? This is a very small idea, but it's just having the glass together with insulation, with a fixture which doesn't need the typical frame. So you have a glass in continuity with insulation. And that frame glass, apart from being nice and cool, of course, you need to test it. So this is a product that has been designed, produced, testing prototypes, so you know it works. But that creates a very nice compound without silicon, we see everywhere, right? And without much fuss. Okay, small idea, small detail. Of course, you need to develop it and see how it works. And see the publications, right? And you see the performance. So they go almost half the transmittance that we have the standard plastic PVC. We complain about plastics, but actually PVC is quite competitive to give you a reasonable insulation with a reasonable cost. And if the maker recycles it, not all makers do it, and you use it for a long time, it makes sense. Again, we cannot say good or bad in terms of sustainability. Things may make sense, right? So you have the system of construction and the simulation for, of course, you make simulations, and those guys are good, they are very serious, but then you make the prototype and test it in laboratory to see how it works. Again, fully mechanical controlled ventilation. This was the paradigm in most construction now. Even in Spain, we are telling, we shouldn't bother anymore about opening windows because of ventilation will be mechanical, so why let's use only fixed glass? But we know we are humans, and we like to open the windows to sit outside and to have the clean air, to smell the pines, to smell the cars. We don't know what's better, but again, we have to think that as human beings, right, we have some kind of relation with the exterior, which cannot be just engineering. And one more thing, if you have building, you know, this very creative building, you have ventilation system with fans to take the air out. Those fans are noisy. And the good ones are noisy, the bad ones are very noisy. I have one of those in my office here in Code, and I feel I'm in an airplane when they put it. Actually, it's like 50 decibels or 60 decibels when it's turned on. So that makes people just turn off and not use it anymore. The second thing is that they usually have filters, which is good for allergy and so on, allergies and so on. But if you filter, you have an effect in which you have the interior microbiome. So you have full of bacteria, viruses, fungi, and so on. If you enclose totally the exterior, those bacteria overgrow, and you have very terrible environment. If you have exchange with exterior, you have another bacteria which come in and they have some kind of balance. But the moment you totally isolate it, we have worse environment than we would have just opening the windows. And this is the plan of the surgical rooms, for example. We have the super box, which also have to deal with this. So very careful with this mechanical ventilation or those filters. You may end spending more energy than you planned. And again, we have such, we speak of Korea, such a nice tradition of opening totally the facades to have plenty of air in summer, then making very small rooms with ondol in winter. So you can heat it with almost no energy, that we make buildings which can open a tiny fraction of the window and work only on mechanical ventilation. This is a Sampung apartments, very expensive. I know somebody who went to live here. After the first summer, they left. Because of course you can put air conditioning in summer, and maybe it is not so expensive, you can pay for it. But being under the sunshine with air conditioned is like being in the bus or in the car under the sunshine with the car air conditioned. It's terrible, right? So there's no way to live there. So when you design your facades, and I guess many of you design towers or buildings with huge windows and so on, plan very well for it. Tradition, if you see any kind of hanok or so on, or old building, without nobody telling you, will recognize the north-south facades, right? Because they work differently. But in many buildings, we just produce the same facade on all four sides. And that creates a lot of disasters and very inhabitable spaces. Of course, we have beautiful projects. And I think the open air school was something which came from the old pandemics, right? Actually, the need of ventilation. And what is bad of having people in open air, right? If the exterior is healthy enough. And again, we have the small ideas, and then we go to my friends of BSA, the UBLO, in which you can have small openings which just take care of the minimum of ventilation without needing to open the windows, right? So of course, opening the windows is always nice, but you may have this kind of minimum air without fans. You can decide on the filters or not, and making sure you have always a healthy environment. There are many more things. We have also air filters in the sash or the frames of the windows, which usually come from Finland, Canada, right? All those countries that have so much cold air that they know you need ventilation. So they have this kind of filters. If you see, for example, projects by, I remember now, Villa Marea, right, Alvar Aalto, you see that has windows which are glass and small window, which is just solid timber, which is open only for ventilation. So you have this kind of element which ventilates. You don't have such huge opening, so you can have new air without having a big energy loss. Again, these are small things that may make things better than the usual, right? And then I think we go to the end of the lecture because I promised 1 hour. And also we started a bit late. We are almost close to the 1 hour time. The clean energy. And this is one of the things we often say. This building is great because it has solar panels. You have to check, okay, yes. But what's the function of solar panels, right? Most times they're just decoration, or they're just putting light to the small LED you have in the facade, maybe accounting for 0.001% of the energy of the building. So again, clean energy, as in the case of the Seoul Energy Global Center or Dream Center, made sense because it is produced, but it's not always an easy decision. One thing that may encourage us to use clean energy is this is something published in 2011, but still actual. It's about the energy produced in the world. Beautiful graph, actually it's very classical way of doing, but it's a way to show a lot of data in very few numbers. It shows that clean energy is a very small part of the full energy, mostly it's coal, gas, right? But the important thing is here, we have over 50%, probably more than that, I cannot read the numbers, is lost forever before you can ever use it. And this is already in the 21st century. Our technology for energy management is so poor that we have to produce twice as much energy we need. If we can solve this, we had suddenly twice the energy we have, which is big development, but we don't know how to do it. One of the things to avoid this is to use that self-generated clean energy, which at least you have not transportation loss, right? It's one thing we can consider. And because really it is difficult. This is an example I borrowed from one of my colleagues here. Actually, Professor Won was working at SOM, and she took charge of this building. So it was a very serious study of a turbine in one of the towers of SOM. So this is a really serious study. And it took months and many hours of study. And those turbines you will see published in places telling, come on, they have turbines that are so green and so great. Well, after the study, it was helping only 0.003% of the total energy consumption. So there was not any point of using that. You put only the hole for decoration or to show things, but there is not use of that. So you need, of course, to have the idea and test it. But if the numbers do not work, reality will be probably even worse. So careful with those things. Don't believe every image is published. And I will put something more pedestrian, more, that's Spanish, more everyday. This is one exercise I did in sustainability course, right? To see about solar panels reality. And we took 1,000 square meters office building in Seoul. We didn't need to go to the small numbers. Only the idea was to have 50%, right? 50% of the energy by solar panels. You have the area and the energy consumption and the cost based on standards of Korea by 2015. So 50% of his energy. We made the calculations. Well, I made. So here's the thing with the panels we have. I found the best panels by LG at the market price, right? So we needed, first thing you will consider is that you need 300 square meters for a building of 1,000 square meters for just 50% of the energy, right? So you need a lot of space. If you want to have 100% by solar energy, you have no space to put them because that's the footprint of this building. This building is 330 square meters. So the one thing we see, we need a lot of panels. And that was not cheap. This was a lot of money. But then you save money. Well, the calculation, and you know the calculation, if you save 1 million a year, doesn't mean you save 10 million in 10 years because the value of money is less year by year. So the calculation with the present value, in 15 years, there was no payback. You will still pay money. So I did the calculation and it took 26 years just to pay back the investment. And 26 years, probably the panels are in the end of their life. And I didn't consider that the panels also lose efficiency. I didn't consider only just the inflation rate on that time. So what's the problem? Something unique of Korea, in Korea specifically. Electricity is crazy cheap for companies. Then there is no any reason for doing clean energy because it doesn't pay back. And probably after 6 years, these numbers are a bit better, but come on, who wants to spend money if it doesn't pay back? It's all business and the shareholders asking for benefits. So when you see those solar panels are just a small little bit, just to show it, but really not a significant part of the production of energy. But let's see what happens with the house. Again, this is a small house. this is the cost of energy, and this is what surprised me. This is 2010, I didn't update, but if you have a big house, you're paying much, much more for electricity than the companies. So I'm sorry to say, Korean families are paying the electricity of Samsung, LG, and all those guys. But okay, that's how things are, I cannot change it. So we have the calculations, the cost he had, and again, how much would need, how would it work with solar panels just to 50% of the bill. This is the calculation. So again, we need to have 40 square meters of panels for a house of 100 square meters. And that's only for 50%. Again, we need a lot of panels. The cost, of course, for one house, you may think is not exaggerate, but curiously, in this case, in 1 year, the investment pays back. And this is because the energy is so outrageously expensive for houses. So if you're doing housing, put solar panels, because there's no question, you will save a lot of money. Then you can speak to your government about how that is planned, right? And you may be a bit more demanding to Samsung and those big guys, because since we all work for them, not them for us, but so we are paying their bills. Okay, so, and we have more tools, of course. You may have we have already available the batteries in which you can accumulate energy, right? We have a very recent development. Australians are making hydrogen fuel, which can be domestic and safe. It is very expensive and long durable. The problem with solar panels is they produce electricity in the daytime, right? So this may help. And this means controlling the panels that you have to really plan them because they will affect the design. This is just a small room. And we are checking the possibility just to accumulate the energy in storage in water. So, but actually you need a huge amount of water to have a little bit of energy, but still there are things to consider in this energy saving. And there are many, many more things. So again, the hour went by. So probably you're disappointed because you say, Professor, what are those details we need for our project? You have to look around, but probably you have some tips, right, which affect the design. And you hopefully will be also clear about how important are your decisions in terms of design. What's the bottom line? Okay, I would not be as the skeptic of the first slide, but I have this quotation. I took it a little bit. Architecture is my word, but architecture is an assault by man upon nature. It is a human action against nature. A human organism designed for shelter and work, it's a creation. Okay. This is the thing. So any construction is against the nature. We are just trying to fight against it. That's true. And this is Le Corbusier, which in his book Urbanism, he says that. Then says, okay, it is so much an effect of nature that we have to be really serious about what we do. So he was not telling, we don't make more cities. Actually, he said it's a city, right? It's an assault by man, but I teach architecture. But that's not the point. The point is that we have to be very serious so that aggression to nature is compensated by the human activity we put there. So it's not just energy and efficiency. It's about the whole meaning of the buildings we create. And of course, if we have read it, there is not eco-friendly architecture, right? Because it is always against nature. So you can be morally sustainable, but come on, forget, please, do not use this term. I don't question the Tsinghua, which is the same in Chinese, but eco-friendliness is just meaningless. So I can just conclude. This is my final words, and you can ask questions if you want. Good architecture is sustainable by definition, just to some degree. And this degree is what we have to evaluate. This trade-off so creates sustainability, right? But if your building is not sustainable, that's not good architecture. And I think that's the bottom line, and what we should consider. That means that you have to study a lot on good construction. You have to analyze good buildings, not just the famous or very publicized. You need to have a very basic knowledge of things, but above all, you have to be good architects. So please listen to your instructors and do better design over and over. So I end here, and I wonder if you have any question or comment about this. This is all I could do in 1 hour of time. Yeah, 1 hour and 5 minutes. Professor Brossa. Oh.
Santiago, thank you so much. This was like a lot, very meaningful, and
Really?
and I learned a lot actually. So I really appreciate having had this initiative. I mean, for my students, I decided to join Professor Santiago Porras' class because I thought it would be it's a meaningful. It's a very, very meaningful amount of knowledge for the point where we are, and as we're developing into the project. Of course, he's not giving you the solutions. That's up to you, but he's giving directions, and I think that's what matters. So there's no recipes for success, but there is strategies, and yeah, like I thank you so much. This was a lot. I didn't expect it actually so much.
Well, I don't know if you didn't expect. I don't know if I'm happy or not happy because you didn't.
No, I didn't see. I've had this idea, but I never expected the depth of the meaning, and because you've been working on this for such a long time that you were able to compact all this amount of information in a very useful format. I totally agree that asking someone to talk about a sustainable architecture in 1 hour is like trying to kill an elephant with a toothpick. But I think it was very, it's more like providing a framework to start even thinking about it. And I think that's very valuable.
Right.
So it's priceless.
Okay.
Actually.
Well, thank you so much. It's very kind comment. So, well, actually, I told you, I'm so used to this. I don't know if I'm telling things which are too obvious, which everybody knows or everybody should know, but I think there's so much basic, right? That should be like our embodied thought already. It's not as architects, as humans, we have to be part of this attitude of being more, yeah, I don't know, more reasonable. I don't know. Anyhow, that's very kind comment, and I really enjoyed sharing the lecture and having it with you. So whatever, if you have any question or
many questions, but I don't think we can answer them.
Yeah, surely I cannot answer them. Okay, maybe if there is nothing more, let me take a screenshot because we have 5 people on the screen now. This is the.
Can you guys turn on the screen, please? 1 second.
Yes, I think you can. You want to share? Just 1 second. Just for the photo. Good. Yes. Wow. So many people.
Everybody. More.
Everybody.
Wake up.
And we have my class is wow. Wow. People are adding.
People are
so many people.
up.
Everybody. Yes. So I tried not to shout too much. So people sleeping would not be woken up too much. Okay. So the photo is taken now, so you can just hide again. So I will share with Professor Brossa the handout, so you have the slides and the images.
Okay, thank you.
And the recording will be posted in YouTube in not private, but unlisted link, so you can go back to it. And then you can find the mistakes and errors, and you can tell me things to fix and to improve. Or whatever. Okay.
Thank you so much.
So, yeah, thank you so much for inviting. And okay, let's meet again in some critic.
Yes.
And I
have a nice class studio. We
did not decide, but we have to fix the date. So we have some useful critics here. And I was going to say something, but I would just repeat only one more thing. Listen to your design professor. You have to make a good project. Okay. Good. Okay, so let's end here then. Thank you. Goodbye.
감사합니다. So guys, in my class, we'll just follow the schedule appointments from the calendar. Thank you. See you soon.
Okay. Goodbye.
Thank you, Santiago.
Bye-bye.
Thank you, sir.